Hello everyone, myself Dr. Ashalata KS. Now we shall discuss about polar coordinates. Let P be a fixed point known as pole. This is known as pole. R the origin and OX be the fixed straight line known as initial line or polar axis. This is known as the initial line or polar axis. Let P be any point on the plane containing the point O and the line OX, that is join OP. Let OP equal to R be the length and theta be the angle made by OP with the positive direction of the x-axis, that is initial line. Then the two fixed quantities R and theta taken together are called the polar coordinates of the point P, which is denoted by the symbol P of R comma theta. In particular, R is called the radial distance or radius vector of the point P, and the angle XOP equal to theta is called the polar angle or vectorial angle of the point P. So this is called the length OP, that is R. This is called radius vector and this angle is called the vectorial angle. That vectorial angle varies from 0 to 2 pi. Theta is considered as positive when measured in the anti-clockwise direction from the initial line, and R is generally taken as positive quantity. The system representing a point on a plane by means of polar coordinates is called the polar coordinate system. Now we shall know the relation between Cartesian and polar coordinates of a point. Let the pole O be taken as origin, the initial line OX as x-axis, and a line OY perpendicular to OX through O as y-axis. If it makes OM equal to x and PM equal to y. Observe here, OM equal to x and PM equal to y. Then in the Cartesian coordinate system, the point P of R comma theta is represented by P of x comma y. Then from the right angle triangle OPM, we get cos theta is nothing but OM divided by OP. OM cos theta is nothing but adjacent by hypotenuse. OM divided by OP, that is x divided by R. Cos theta equal to x by R, or x equal to, cross multiply this, x equal to R cos theta. Call this as equation 1. Sin theta is nothing but opposite by hypotenuse, that is PM by OP. Sin theta is nothing but opposite PM by hypotenuse OP. So sin theta equal to y by r. Cross multiply this, y equal to r into sin theta. So the relations 1 and to determine the Cartesian coordinates of the point P in terms of the polar coordinates. These two are the Cartesian coordinates and these two are the polar coordinates. 1 and 2 represent Cartesian coordinates in terms of polar coordinates. Now, squaring and adding equation 1 and 2, we get x square plus y square equal to r square into cos square theta plus sin square theta, which implies x square plus y square equal to r square. R is nothing but root of x square plus y square. Call it as equation 3. Now divide equation 2 and 1. Which is that equation 2 and 1? These two. Divide equation 2 by 1. That is r sin theta by r cos theta, which is equal to y by x. So we'll have r sin theta by r cos theta. R get cancelled. Sin theta by cos theta is tan theta, which is nothing but y by x, which implies theta equal to tan inverse of y by x. Now, thus the relation 1 and 2 enable us to convert the Cartesian coordinates x comma y of the point P in terms of the polar coordinates r comma theta. Whereas the relation 3 and 4 enable us to convert the polar coordinates r comma theta in terms of Cartesian coordinates x comma y. As the point P of r comma theta varies along the curve, both r and theta vary. Hence, the equation to the curve in the polar form is denoted by r equal to f of theta and is called polar equation, and the curve whose equation is given in the polar form is usually called the polar curve.